Okay, so let's do some more examples, but before I go into some examples, let me explain a couple things. A lot of times when you have a single trigonometric function, like sine and cosine, then it's just a matter of understanding the unit square and using, or not the unit square, the unit circle, and solving for a particular angle, either for all exact solutions or for a particular interval. When you're dealing with the reciprocal functions, though, you have to be careful and you have to look at them algebraically. So you have to write the reciprocal function, and then you also have to consider the domain, right? And you have to consider the period, okay? And so that becomes something you have to be aware of, okay? The other thing too is when you're dealing with tangent, tangent has a different period. Remember what I said earlier, it has a period of pi and not 2 pi. It also has a asymptotes, right? It has asymptotes at every odd power, or excuse me, at every odd multiple of pi over 2, right? So that's other things you have to be consider. Okay, so let's do some more examples here. So now, the first one gives us this, so we're going to solve this, okay, and given the interval, that's the interval we're interested in. And so again, we're just going to solve this, and we're going to solve it for sine squared. Now notice we have sine squared here, so we're going to end up having to take the square root and use the root property to solve this. So we'll have to see what happens there. So now what I'm going to do is I'm going to isolate sine squared. So I'm going to add 1 to both sides. Okay. And so that's going to give me 2 sine squared theta is equal to 1. And I'm just going to divide both sides by 2, right? And so I get sine squared theta equals 1/2. And then this is where I'm going to use the square root property. And so if I take the square root of both sides, that's going to give me sine theta is equal to plus or minus the square root of 1 over 2. Now, this is going to give me what? Plus or minus what? This is, well, the square root of 1 is 1 over the square root of 2, but I can't have the square root of 2 in the denominator, so I'm going to have to rationalize this. So this will give me the square root of 2 over 2. Okay? Again, remember, it's just going to give me 1 over the square root of 2, plus or minus, and then I have to multiply the top and the bottom by square root of 2. And that's where I get this. Now, in this case here, I'm looking for the angles, right? I'm looking for theta that when I take the sine of that angle, that it's going to give me plus or minus square root of 2 over 2. Okay, and in this case there are 4 angles. Okay, so think about this. We don't care if it's plus or minus, so that means there's going to be an angle in every single quadrant that's going to give us square root of 2 over 2. And by the way, what angles give us square root of 2 over 2? Well, let's just look at the easiest one, which is the first quadrant, right? And so what type of triangle gives us 1 over the square root of 2? Okay? 1 over the square root of 2, right? So opposite over hypotenuse. Okay? So that's going to be like this. It's going to be a 45-45 angle, right? So that means, guess what? If I'm looking at the unit circle, I'm going to have a 45-degree angle here. I'm going to have a 45-degree angle here. I'm going to have a 45-degree angle here. And I'm going to have a 45-degree angle here. So I'm going to have 1, 2, 3, 4 angles. Well, that's going to be what? Pi over 4. Okay? This is going to be what? 3 pi over 4. Okay? And then 5 pi over 4. And this is going to be 7 pi over 4. And so those are the 4 angles that is going to give me either positive or negative. So it's going to be, so the four solutions, so from 0 to 4 pi, oh, excuse me, I'm sorry, from 0 to 2 pi, the four solutions is going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, now, that's the first one. Okay, now what about the second one? The second example is cosecant, so we're dealing with something other than sine, right? So we're dealing with a reciprocal function. So cosine theta equals -2, and we want the angle from 0 to 4 pi. 0 to 4 pi. Okay. Okay, let's look at this. First thing I'm going to do is I'm going to write this in terms of the reciprocal function. So this is going to be equal to 1 over sine theta equals -2. So now if I solve for sine, that's going to give me sine theta is equal to -1/2. Okay, so now I need to know what angle from 0 to 4 pi. Now here's the thing, you gotta be careful. Sine cannot be 0, right? The sine of this angle cannot be 0. Okay? But if we solve it for sine, then we're okay with that. Okay? So let's figure it out. By the way, as you know, this will never happen for this solution, right? We're looking at these solutions. None of these solutions are going to give us some multiple of pi, right? Because that's the only time that sine is going to be 0, is so for some multiple of pi. And so, as you'll see, none of these will be a multiple of pi, as you're going to find out, because you should already know or have an idea what kind of triangle this is. So it's negative, right? So sine is only negative in which quadrants? Well, is going to be the third and fourth quadrant. Okay? So let's consider that. Okay? So, if we just look at just the first quadrant, just to find out what kind of triangle we have, okay, we have theta, and so it's going to be opposite, so this is going to be 1 over 2, right? And so, oh, I'm sorry, hypotenuse, 2. And so guess what? We have a 30, 60, 90 triangle where theta is 30 degrees. Awesome. So now, what angles from 0 to 4 pi, 0 to 4 pi, notice that we're doing 2 revolutions around the circle. So that means if we go from 2 pi, what are the 2 angles in the third and fourth quadrant that will give us -1/2? Well, the first one is going to be, well, since we're dealing with a 30-degree angle, it's going to be, and again, just picture this, right? So here's a unit triangle, so we're going to have an angle here, right? So we're going to have an angle here, and an angle there, right? So this is going to be an angle, and this is going to be an angle here, okay? So what's this angle? Well, this is going to be pi, right? So that's going to be, if we're talking about 30-degree angles, that's pi over 6. So in this case, this is going to be 7 pi over 6 because you're going to go to pi, which is 6 pi over 6, and then one more pi over 6, which is 7 pi over 6. So that's going to be one of our answers, is 7 pi over 6. And the other one is negative pi over 6, or in other words, it's going to be 11 pi over 6, because 2 pi, right? 2 pi is 12 pi over 6. So if you subtract one of those, you get 11 pi over 6. So you know your two answers, your two angles, are going to be 7 pi over 6 and 11 pi over 6. And guess what? Now, that's from 0 to 2 pi. So now to get the other two, all we're going to do is one more revolution. So we're going to just add, 2 pi to this. So guess what? So we're going to add another 12 pi over 6, which is the same as 2 pi, right? So because we've got common denominators here. So if we add 12 to 7, we get the next one, which is 19 pi over 6. And if we add 12 pi to this one, 12 pi over 6 to this one, we get 23 pi over 6. And those are the only solutions from 0 to 4 pi. Okay? And that's it. Have a great day.